You're welcome to Pratham Science Academy classes. We are here once again to solve one of the numericals from the laws of motion class 11th physics. And it's given that let's read out the problem. So it's two identical billiard balls. They strike a rigid wall with same speed but with different angles and get reflected without any loss of speed. So these are the two identical billiard balls, means mass of both of them is same. So let's consider their mass to be m. Now it's given that one of the balls strikes the wall normally and gets reflected normally, while the other ball strikes at an angle of 30 degrees to the normal to the wall and gets reflected at the same angle. We have to calculate the direction of force on the wall due to each ball and the ratio of the magnitude of the impulses imparted on the two balls by the wall. Okay, let's consider the first scenario where the ball strikes normally and is reflected normally. That is the case one. And let's say this is a rigid wall, and it's given that the ball strikes the wall normally, gets affected normally without any loss of speed. So that means it strikes the ball with the same speed and is reflected with the same speed. So let's convert this speed into velocity. So how do we convert the speed into the velocity? By giving them the direction. So these balls reflected normally along the same path. So let's consider this speed as positive. So this is, and this speed as negative. So we have converted the speed into the velocity. Now we have to calculate the direction of force on the wall due to each ball. So here we cannot apply force is equal to mass into acceleration. So we have to use the concept of the impulse because the impact is for a very short time. So in this case, let's say the force is F1 and we know that the force is given by m into v minus u, that is change in momentum by time. And this is equal to, let's put in so the final velocity here is negative u and minus the initial velocity is u. So that is has to be divided by time. So this is the force exerted by the ball on, so minus u is minus 2u into m into t. So this is the force exerted by the wall on ball. But we have to find the direction which is along the positive, along the negative x direction. So this is a force exerted by wall on the ball. But it's given that we have to find the force on the wall due to each ball. So it's here there is a negative sign. So this means this is in the opposite direction. The force exerted by the wall is along the positive x direction. So this force F1, we can say that the force exerted by wall on wall is F1, its magnitude, and this is along positive x-axis. Because this force is a force exerted by the wall, and the negative side indicates that this is along negative x-axis. So the force exerted by the wall of the wall is normally is F1 and is, we can say, we can write here as normally along positive x-axis. Okay, let's move on to the second scenario where it's given. Okay, in the second scenario, it's given that the ball strikes with an angle of 30 degrees with the normals. Okay, so with the same without any loss of speed. So that means let's change the speed into, let's take this as positive and take this as negative, and this is the normal. So this is making an angle of 30 degrees with the normal. So this is 30 degrees with the normal, angle of incidence and angle of reflection. Now we calculate the force, the direction of the force. So let's calculate the force exerted by the wall on each wall, and let's see what its direction is. Okay. Now in this case here, this initial velocity u has two components. Okay, it has two components. Let's say these are the two rectangular components. Now, because this angle is 30 degree, so these two lines are parallel, so these are alternate interior angles, so this is also 30 degree. And now this is the horizontal component, which is u cos 30, and that is u sine 30 degree. Okay, similarly here, this is the ball is coming in this direction. So here also we have two rectangular components of the velocity, which is negative, that is the direction. We have given it the direction now because this angle is 30 degree and these two lines are parallel. This is the transversal, so this angle is also 30 degree. Okay, now this component is negative u cos 30 degree and this is negative u sine 30 degree. Okay, now the vertical components u sine 30 and negative u sine 30, these two will cancel out each other because they're in the same direction but with the different signs. So the net velocity along the y component, the net velocity along the y component is on along y-axis is u sine 30 plus negative u sine 30, which gets cancelled. This is equal to 0. So that means only these two components, the horizontal components, are playing the role in reflecting the ball at an angle of 30 degree. So here, the force on wall due to this ball is equal to change in momentum divided by time. So here the final velocity is this negative u cos 30 degree. So this is negative u cos 30 degree minus the initial velocity was u cos 30 degree. Components are cancelled out. So this is negative u cos 30 degree divided by the time. So that it gives me minus 2. This is 2 times minus 2 mu cos 30 degree divided by because this is the force on the wall due to the ball, which is which shows a negative sign, that is this is along the negative x-axis, so that means the force on wall due to the second ball is normally along positive x-axis. So the force and its magnitude is, let's say this is the force F2 and this is the force F1. And its magnitude will be the magnitude of F2. Okay, so we are just done with finding out the force on wall due to ball in both the cases. Now the second, which is normally along the positive x-axis in both the cases, now we have to find the ratio of the magnitude of the impulses imparted on the two walls by the wall. So ratio of the magnitude of the two impulses, ratio of the magnitude of the impulses imparted on the two walls by the wall. So the impulse, we know that impulse is, this is the impulse which is, so the ratio of impulses in both the cases, and we know that the impulse is either change in momentum or force into time. Okay. So impulse in both the cases, we know that the formula for the impulse is force into small time interval. So then the first case, the force is, or let's say the impulse here. In this first case, the impulse is minus 2 um. So I can write here it's minus. So this is the change in momentum because this is the change in momentum. And we know that impulse is either given by force into small time interval or impulse is equal to change in momentum. So we already have the change in momentum in both the cases. So this is the change in momentum in the first case, which was minus 2u by m. And in the second case, it was minus 2 mu by cos 30 degrees. So this 2 gets cancelled, u gets cancelled. And now we are left with 1 upon cos 30 degree. And we know that cos 30 degree is root 3 by 2. Cos 60 is half, cos 30 is root 3 by 2, which gives us the value 2 is to 2, 2 is to root 3. So the ratio of impulses in two cases is 2 is to 3, which is the change in momentum in the first case and the change in momentum in the second case. Okay, with this, we are done with this one. Do like, share, and subscribe. Thank you for watching.